All right, so yeah, as I said, I started working on this in my postdoc with David Weir, who is the principal investigator of the health and retirement study. He is also an economist, but does a lot of work in demography and aging. So this was something that we just kind of started to explore, and then it kept developing into a paper. And as I've gotten deeper into the work, I kind of keep picking it up and putting it down. But as I get deeper and deeper into it, this was just such a rich time period in the United States, and there was so much going on. And also there's a huge literature in economics around what I'm going to be presenting today. So how I'm building on things is really by bringing genetics to the table and seeing what we can learn from that. And if that adds to the current theory and what we know in any meaningful ways. So like I said, feel free to interrupt as I go. All right. So this is where it might get tricky. I'm going to have to put you guys down here. Okay. So there were two research questions we wanted to attack. The first was, did substantial expansions in high school completion in the United States during the first half of the 20th century reduce genetic disparities in educational attainment and lifetime earnings? And I'll talk more about what I mean by expansions in high school completion. And the second is that what we're going to see is that there was kind of this flattening of the genetic gradient in high school completion alongside these huge expansions. And so the second question is then, was this flattening of the genetic gradient driven primarily by changes in the quantity of schooling, or did the quality of schooling also play a role? And did these effects vary by an individual's polygenic index? I want to pause for a second because I think we're all coming from different disciplines. And some of us have been used to saying polygenic score. Some of us have been, polygenic risk score, genetic risk score. So we're all talking about the same concept. This polygenic index is starting to be adopted now more. It was a term that was put forth by the Social Science and Genetics Association Consortium to kind of take away any sort of potential value or kind of normative judgments that people were placing on the term polygenic score, which makes it sound like, I'm higher, better than you, and rather just talking about it more as an index that might, be measuring potential underlying genetic influences. So just to point that out as we go along.
And quantity of schooling has a meaning here, which you mean credentials, more years of schooling or credentials of schooling, like whether you graduate high school, yes, no, versus quality, like the type of high school and that kind of thing.
Yep, exactly. So quantity is how much schooling you've obtained, and quality is, there's these traditional kind of metrics that people have looked at, especially in econ, and I'll talk more about that. But typically measured by looking at like average term length, how much teachers are paid, which is a good kind of benchmark of how much the school system values teachers and things like that. And their role in the classroom, and people to teacher ratios. So, how many students are in a classroom with a teacher? And this has been, a long-standing debate in economics because initially there were, a lot of reports that came out in the 60s, I think it was actually the 50s, one report in particular called the Coleman Report, which really showed actually that there was no impact of the quality of schooling, that quality of schooling didn't really matter. Of course, this caused a big kind of hubbub in the field, and especially in education, because it was kind of like saying, hey, it doesn't matter about, how we implement policy doesn't matter in terms of the quality of someone's education. And so that then spurred a whole kind of series of papers by economists, most famously Card and Kruger, Alan Kruger and David Card, who then really kind of wanted to take a more serious look at the quality of schooling, do a lot more kind of causal modeling with that. And they found that when they kind of looked at state level differences in terms of how they were aggregating the data, which you'll see today, I'm going to be, following in their footsteps of how they aggregated that data. They did see a strong role of school quality. So this has been this kind of back and forth debate in the literature.
I have a question. So first, I wasn't sure what you meant by genetic disparity here, but by the second point, it seems that you're talking about maybe a reduced predictive performance of polygenic index on the outcomes you're interested in. But in this sense, I wonder if you're treating these scores as a objective measure or something that can change over time, because these scores are not like height or BMI that you can just get value for, right? They actually depend on the weights from a GWAS, and the GWAS is conducted for a certain time period, right? Mm-hmm. So if you do the GWAS for people who were born in the 20s and people who were born last year, the weights will look very different. So I just wonder what you mean by, for example, the flattening of the genetic gradient.
Yeah, no, thank you. That's a great question. And yeah, it's you'll kind of understand more as I go along and see some of the results. But basically here, I mean that the effect of genetics as measured by a polygenic index, because you're right that the index value might change as we get more people in our GWAS, as we expand, as we look at more across cohorts. The value of that index on somebody's outcomes may vary depending on their socioeconomic background. And in this case, it was kind of the schooling environment in their state. And so what we see is that individuals with lower polygenic indices, as measured here, were more likely to complete high school, regardless of their kind of index or background. So it basically is kind of referring to moderation of the score by the environment.
Yeah, but here your score is a snapshot, right? It's based on maybe year 3 paper.
Right.
So you're talking about how the effect of this particular score change when comparing different generations or in people in different environments that are associated with time.
Not really that the score is changing. So or the effect, but more that the effect of the score might vary across environments. That makes sense.
It's not the score change, but the effect of the score.
The effect of the score, yeah.
And it happens to be the case that the data, the health and retirement study is like, I think implicitly Lauren will say it's like a reasonable set of birth cohorts as compared to the GWAS samples, like the UK Biobank are like really similar in birth years as HRS. Like it turns out that we don't know the answer to whether if the HRS were all young people from like 2010 and 2020 and stuff, whether that would make a big difference. But I think in your mind, I mean, it's true that Hugh's point is exactly right. There's this one set of beta weights that's like this mishmash of a bunch of cohorts that have all been piled into the EA3 or EA2, whichever one you're using, and you're looking at the effects across birth cohorts. But those are different people who, if you would have done GWAS on each of the birth cohorts, you might have gotten different polygenic index indices, right? This is partly your point.
Yeah. So in a way, I'm kind of holding. I'm assuming that it's the average effect across all these cohorts, and so I'm kind of holding that constant in a way while investigating these different environments that were going on around them.
There's a comment in chat with.
So it's going to need to leave.
Yeah, I wonder.
In an hour.
Okay.
In now in 30 minutes.
Now in 30 minutes. Okay. Okay. So, what do I mean by 20th century expansions in education? So here you see the on the x-axis here I have birth cohort, or so the year you were born. And then on the y-axis, I have average years of education for that birth cohort. And you can see there was this really huge increase over time, especially between 1900 and 1945 birth cohorts. Things kind of leveled off around 1950, 1955, but still some growth there. And if we look at this same figure, but for high school completion rates, you can see that it was really being driven, that huge increase was really being driven by increases in high school completion. And this in the literature is known as the high school movement. And I'll talk a little bit more about why this was such a unique phenomenon in the United States during this time period. And, notably, sorry, I keep losing my cursor, notably, the cohorts that we'll be looking at today were born between 1930 and 1960 about. So we're capturing kind of this snapshot of the rise. So what was the high school movement? It was really this rapid growth of secondary schooling in the first half of the 20th century. This has been flagged as really a uniquely American phenomenon. The rate of increase was nothing short of spectacular. I'm just quoting other scholars here, Claudia Golden, and levels were the levels that were attained were unequaled by any other country until much later in the century. The growth was fastest between 1910 and 1940, but the movement really continued through the 1970s. And it was really driven in part by increased demand for an education that would lead directly to white-collar employment and not necessarily college itself. So the idea was that high school would become a place where people could also learn the skills that they needed to enter directly into a good-paying white-collar job after they graduated. So like a sales or admin position where they, rather than going into manufacturing or more blue-collar employment. And then, of course, as time has gone on, we've seen, that more and more people are going to college. And so now we almost see like a college movement that's happened, for the second part of the century. But the thought was, in the early 20th century, this was more that high school would give everybody what they needed to be part of the educated white-collar workforce. Importantly for our study today, these expansions in education really varied by state. So here you can just see quartiles of mean educational attainment. This is years of education, but again, it's really being driven by high school. I'm just looking here at the health and retirement study data. This is across all the cohorts, so it's not a snapshot by birth year, but across all birth years, it's kind of the average. But what you see is these clusterings that we're very familiar with in the United States. So the lowest kind of educational attainment rates are in the South, and then the highest were kind of in the West Mountain region, a little bit here in the Northeast. A lot of what you see in the Midwest was really the reason why it wasn't quite as high as some of these other areas was the enormous emphasis in these states on manufacturing. So a lot of individuals would kind of go into manufacturing, especially if the wages were high. Also, a lot of these people, may have been just starting to kind of be old enough to be in the workforce when World War II hit, and there was an increased demand for people who could work in manufacturing. So that's kind of explaining some of these, national patterns that we're seeing. So what I'm going to do today is exploit variation in high school completion rates across states and over time to examine whether these changing trends modified the relationship between a genetic predictor or index for educational attainment and socioeconomic success. So let's just quickly go through the data, sample, and measures. I'm going to go through this a little bit more quickly because I think a lot of us are familiar with HRS, but stop me if you have questions. HRS is a biennial national representative study of individuals over the age of 50 and their spouses. Began in 1992. They're currently in the 2020 wave. Here I'm going to be focusing on individuals again born between 1930 and 1959. What I'm going to be doing is linking genotype data from the health and retirement study with sociodemographic data at baseline. Then I'm going to be linking this with data on lifetime earnings. These are administrative data from the Social Security Administration, so they're based on actual tax records. They are actual earnings records. And then I'm also going to be using the US Census to calculate state and cohort specific educational attainment rates for these different cohorts. And then finally, for the school quality measures, we're going to be bringing in data from the biennial survey of education or the digest of educational statistics. In terms of outcomes, we're going to be looking at education, as Jason was saying, total years of education, and then dichotomous variables for whether a respondent completed each degree level. So GED, high school plus, whether then they went on to get an associate's degree, a bachelor's degree, et cetera. But really today, I'm going to be focusing primarily on this one because this was really, again, the relevant margin for these cohorts. So that's really going to be the primary focus. The second outcome is lifetime earnings at age 55. So this is the sum of respondent earnings from these SSA administrative records up to age 55. I'm also going to be showing you results that have cumulative earnings earlier in the life course. So originally I was only looking kind of at earnings at age 55, but as I started to dig deeper, I thought there's a lot of value to be learned about these associations and how they were playing out earlier in the life course in terms of cumulative earnings. So we'll be looking at earnings at age 35, age 40, 45, 50, 55, et cetera. We're going to be including earnings from OASDI covered and non-covered employment and self-employment. These are taxes that are, taken away on our paychecks. And so they're recorded by the Social Security Administration in terms of how much earnings you're producing. That's, important for them to know. So that's how we're getting these earnings information. There were several imputation steps that were needed, so I'm not going to go into that, but that was done by researchers at the University of Michigan back in 2018. We worked with them to do these imputation steps because, importantly, individuals who make over a certain amount of money and their earnings sometimes are capped, so you can't see, those really high earners. There were also changes in the Social Security tax ceiling over the time periods that we're going to be looking at. And oftentimes, until at least the 1990s, the Social Security Administration wouldn't always record people's earnings below or above that tax bracket. So to make sure that we're really getting an accurate picture of the earnings distribution, we had to do several imputation steps. Okay. We also do include imputation for non-covered earnings as well, so earnings from self-employment. The first kind of exposure variable that I'm going to be using, or my measure of the environment, you could say, is this measure of average statewide high school completion. So this is the average high school completion rate by state of birth, sex, and 6-year birth cohort. I'm going to be focusing here just on whites because unfortunately, the PGI for educational attainment is not, as predictive in individuals of other ancestral groups. So here just to focus on European ancestry individuals, I should say. When I'm using the census, though, I don't know their ancestry, I just know their race. So their self-reported race. So that's why I'm saying whites here, which I'm hoping is a decent proxy for European ancestry. And I merged these to the HRS by the state the respondent reports living in the longest during their primary schooling years. So I'm not using the state they were born in, but the state that they report being educated in during their primary schooling years. And this is my proxy for aggregate investments in secondary education at the state level is, what was the average graduation rate in the state for somebody who was born, in 1930, what was the average graduation rate for somebody in Colorado and Wisconsin? How likely were you to graduate high school based on that, et cetera? Obviously, an ideal measure would capture differences in investment more at the county or local level. Notably, these differences in investment that were happening in terms of high school completion and the high school movement were really being primarily funded by local property taxes or grassroots movements at the school district level. But state is the finest geographic level we have available for the HRS. And many scholars have also kind of argued that aggregating up to the state level has advantages in terms of exogeneity. You're picking up less on parental preferences in terms of school districts and so forth, and more just kind of on average exposure. So it also has some advantages. Just to kind of show you in the data how this high school completion rate measure is performing in the data. Here I'm just showing the rise in high school completion rates by census division. So I'm aggregating up from state to the census division just because it gets too crazy to show all the states here. But you can see those general trends again by areas in the United States. So New England, Middle Atlantic. Again, New England not necessarily always performing as well as we might think because of that manufacturing backbone. And Mountain Pacific leading the charge there. So, you can see this kind of growth and then this flattening. Our G, our measure of genetics, is going to be a polygenic index for educational attainment. I'm going to be using the one that was constructed by the SSGAC for HRS respondents as part of their polygenic index repository. It's a little bit more powerful because they're also able to include weights with 23andMe. So this is kind of the latest, most up-to-date score. And here I'm just showing how it performs in my sample for different outcomes. So incremental R-squared in terms of prediction for years of education. You can see it's a little bit lower for GED high school degree, which I think is already a little bit indicative that there were some environmental influences perhaps that were playing big roles and graduating from high school for these cohorts, because then you see that the prediction value increases as we get into higher levels of educational attainment. And then for my lifetime earnings cumulative measure at age 55, it doesn't perform quite as well. I need that score from Philip that he's working on, but you can see here it does still have predictive value, but clearly there are also other underlying genetic influences that may be predictive of earnings that go beyond just an individual's educational attainment. So things like soft skills, non-cognitive skills. Any questions so far? Okay. We're also going to be looking at parental education because, of course, this is another huge factor that really comes into play in terms of one's own educational attainment. So in alternative specifications, I'm going to condition on that. It's kind of going to be my primary measure of the family background or the educational environment at home. I'm going to use the self-reports from the HRS of the highest rate of schooling completed by a respondent's mother and father. Importantly, approximately 10% of our analytic sample that has genotype data is missing mother's or father's education. And this is not trivial. It's not missing at random. So we see that individuals who have missing values in terms of self-reports of parental education, that's correlated with a lower polygenic index. On average, it's also correlated with individuals' own educational attainment and their earnings. So we felt it was very important to impute these the best that we could. So we impute missing values separately for males and females using multiple imputation. This is just a picture here of showing some summary statistics. I'm not going to spend too much time on this page. Our overall sample is around 8,700 people. I'm not going to be showing sex-specific outcomes today, but that is something that's going to be part of the study. But the reason I really want to focus more on the combined outcomes is because we're really in this, because this GED high school degree was the relevant margin, we're really kind of identifying off of these individuals who didn't complete a degree. So who were those individuals? You can see this was 10% of the sample, so not a huge part of the sample. So I really want to get as much power as I can by combining that. And you can see it was actually similar across men and women in terms of those who did not complete a degree.
Exactly 10%.
Exactly, yeah. In terms of the empirical model, I'm going to show you a couple different ones as we move through see that. Too many things. I'm going to try to move this guy up here now. Okay. In terms of the empirical model, first, what we're going to look at is the impact of this high school bar. So this average high school at the state level for your birth year cohort. And it's, we have the polygenic, that should be polygenic index here. And its interaction with the polygenic index. This is going to be kind of the variable of interest. We control obviously for sex. I'm going to interact those PCs that are so important with my exposure. Also, of course, going to include the main effect of the PCs. I have birth year fixed effects in here, state fixed effects, region times birth year fixed effects. And then I'm also going to control for a number of state level characteristics that were kind of intertwined with the high school movement. So things like average manufacturing wages at the state level, the proportion of individuals who are employed in the manufacturing industry, how urban is the state, how many foreign-born individuals, how, in terms of race, was a big proportion of the state Black, Gini coefficient. This plays an important role when we think about school quality, which for a long time, of course, unfortunately differed by race. But just to put that in the back of mind, so this is my goal with all of throwing all these things into the model is to try to as closely as I can identify kind of the unique effect of this increase in high school expansion across states. So I want to try to control for these other things that might be confounding it so I can really see the trend in high school completion. In terms of results for that, what we see here is this basically, obviously high school completion rate. If I had I didn't. Okay. The high school completion rate here, the average high school completion rate is highly associated with whether an individual gets a degree. So if your state, had higher high school completion rates, you were more likely to get your high school degree. Here, of course, the polygenic score we see is highly associated. But what is so interesting, I think, is this really strong interaction effect. And it's negative, so it's showing kind of diminishing returns to the polygenic score as the value gets higher. There's less of an advantage, in other words, from having a higher high school completion rate in your state, which would seem to indicate that these higher high school completion rates were really benefiting individuals in the lower terciles of the polygenic score. So we see here a compensatory effect that these two are complements. They're substitutes rather than complements. So that, state policy might be a substitute if we think of this as a proxy for state policy for underlying, genetic propensity, perhaps. I throw a lot of things in there and it still really just doesn't budge. I can't get rid of it. It's a strong effect.
But the units on the completion rate are 1 percentage point change. Like that's,
yes.
The coefficients are small, but that's from each small change.
Yep,
right?
exactly. And so just to show you, because I think it's always like, okay, you showed me this regression table with a bunch of stars, which I know my statistics coefficients or colleagues are like, why with the stars? Anyway, but if we actually graph the marginal effects here, what are we seeing? So this is kind of how we can visually see the model. So this blue line here is a state with average high school completion rates. So a state that was, with above average. So this is if you grew up in a state that was 1 standard deviation above the norm in terms of high school completion rates. And this is if you grew up in a state that was, 1 standard deviation below. And what you can see here is this evidence of moderation of the, polygenic score by where you grew up. So here we have the predicted probability of obtaining a GED or high school degree. This is units of the polygenic score here on the x-axis. And then, standardized, the average is 0. And you can see that for individuals, with really high polygenic indices, they were just as likely to complete high school education, no matter what state they grew up in. Whereas for individuals here in the bottom terciles, there's more of a separation. So if you lived in a high completing state, you were just as likely as someone with a high polygenic index. So this is what I meant when I was saying flattening of the gradient. I don't see for these high completing these high completing states, I don't see a genetic gradient. Whereas for these states with below average high school completion rates, I see a real gradient in whether or not an individual themselves completed a degree by their polygenic index. It's like the index then somehow matters more.
Yeah, this reminds me of a paper we had about being family inequality. I think we showed something like this, some sort of gene by birth order interaction, and posted a preprint. I think it was Elliot Tucker job on Twitter to ask us if it could be explained by some sort of ceiling effect. Because in the blue category, you're talking about pretty low bar, which is high school completion.
Yeah.
It doesn't mean that genetics doesn't actually have impact, just the way you quantify educational attainment. So it's sort of saturated on it.
Exactly. No, and I'll talk about that at the end. Is that I don't know if I can say this is a gene environment interaction, because as you're saying, the variation is pretty constrained in there at the top. And so that might be partially what you're seeing here. But nevertheless, it still happened, in the sense that this was the relevant margin for these cohorts. And individuals, what we're seeing from this model is that individuals were raised in states with higher completion rates, were more likely to graduate high school. And so, the variation was restricted, especially in those states. Whereas in the states below, we see much more variation happening by polygenic index. What's really interesting then is that if we keep looking at that same exposure and its interaction, but we look at different outcomes in terms of educational attainment, here's overall years of education, obviously, strong independent role for high school completion, the polygenic score. here we see again what I just showed you, so the strong negative interaction, but then it flips at higher levels. So it's almost as though it goes from being kind of compensatory or acting as a substitute to acting as a complement at higher values. And so I think this is kind of showing that perhaps where we put the margin in society in terms of what the goals are for policy, that's kind of where we're going to see more of a compensatory effect because the environment is working to moderate the response, whereas higher levels we might not see that. So then I threw parental education in there because obviously this is something that matters. And what I thought was really interesting, so here I have the model without parental education, here I have the model with parental education for each of these same degree outcomes. And I interacted it, with mother's education and father's education. I also have their main effects in there. At these lower values, there's a similar effect, compensatory effect, substitutive effect of an individual's home environment, especially for the mother. And the effect is stronger than that of this kind of state level average. And then again, at higher levels, it's really not there. So I thought that was kind of interesting as well, is that we see similar effects. Notably, it doesn't change the effect on the outcome, this kind of interaction outcome, that is kind of a main interest here. So it really doesn't seem to be explaining that effect or anything like that, which was reassuring to me because I'd like to think that this after including all these controls and everything, that this is more exogenous potentially than an individual's own home environment. So that's maybe kind of, if there was sorting by mother's education or something, we might see this coefficient change.
So if we see a coefficient of negative 0.001, just qualitatively, how big is that effect?
So yeah, so for every 1%, or actually here, it's centered. So I centered the high school completion rate. So for every 1 percentage point increase in the high school completion rate, if you added all these up, you have to add up kind of the full effect, so the marginal effects, everything. But here in terms of the interaction, you see a 0.01% increase in the probability of graduating high school. So the effects are fairly large given, that it's on a percentage point scale. So this is, interesting and so forth. And so I'm showing that quantity of schooling in the state that you really mattered in terms of your own high school completion and that there was a genetic gradient in that. But what about the quality of schooling? So there were increases in human capital investment during this time, but it also included part of the goals in policy were also to increase the quality of the schooling environment. So what I did here is I assessed the impact of two particular school quality metrics, average pupil to teacher ratios and relative teacher salaries, using a two-step model that's been used a lot in the literature on school quality in economics. So in this first step, we're going to run the regression on the individual level. So I'm regressing the probability that you graduate from high school on state fixed effects, birth year fixed effects, sex, the PCs. And then I'm going to take these coefficients here that I get from the state fixed effects, and those are going to become my outcome variable in the second step. And in that step, I'm going to regress these state level effects on average people to teacher ratios and average wages for teachers' relative salaries. And what we do here is that we constrain the sum of these fixed effects to be equal to 0. And when we do that, we can interpret these coefficients as deviations from the mean, from the average country US mean in high school graduation. These coefficients are picking up on deviations from that mean. So in the second step, I can assess how are these people to teacher ratios, these school quality, at the state level, were these averages explaining deviations, and whether or not that state perhaps performed above or below the average in terms of where students graduated. And the advantages of of doing it this way are you really reduce the dimensionality of the data. which ends up getting important, especially for this project, because otherwise you have to kind of include all of these main effects and their interaction effects. The model gets more and more complicated in that individual micro level model, and it gets harder and harder to interpret what you're actually looking at. So I found this particularly useful in this context, because what I'm going to do is I'm going to estimate this first step across everybody, across the full sample, but then I'm also going to estimate these state level deviations by a PGI tercile. So I'm going to stratify each of these by PGI tercile and then estimate this second. So I'll be able to see, and to what degree did these state school level, school quality policies contribute to deviations in high school attainment on average for a given tercile of the PGI. Importantly, I'm also gonna, oops, I went the wrong direction. I'm also going to estimate, oopsie. Sorry, it's a little challenging with this down here. I'm going to estimate this second step using weighted least squares. So I'm going to weight the data for state S by the inverse sampling variance for each state, because I'm not using the census here, so I don't have a huge sample size for each state. And so some states might be more reliable than others in the health and retirement study. The health and retirement study wasn't designed to be representative at the state level. It was designed to be nationally representative. So I want to kind of account for that, potential efficiency loss by using the weighted least squares estimates.
Hey, so looking for
Okay. All right. So here are the school quality results for high school completion. So here you can see for the full sample, on average, higher relative teacher salaries contributed to, likelihood that the state was above the average in terms of high school completion. People to teacher ratios were negative. So they're going in the correct theoretical, direction. So the higher the people to teacher ratio, the more students are in a classroom relative to the teacher. So that tends to reduce outcomes, graduation outcomes. Oops, I don't know why this is so trigger happy. And what I found so interesting, and so here I'm also controlling for division fixed effects in the second step. I'm also then including additional state controls in the second step. You'll see that the outcome, the N is 49. That's because I'm only looking at those beta coefficients for 49 states in the second step. And what's interesting here is that you really just see effects in the lower PGI tercile. So the effects of school quality appear to be particularly salient in the lowest tercile, which kind of was theoretically what I predicted, perhaps. I'm really throwing a lot at the model here. So it's holding up pretty well. The effect sizes are also huge for these individuals compared to the higher terciles, and you can see the effect sizes kind of slowly decline as we go across the terciles. I then also controlled for parental education in that first step. So I also wanted to control for, see if that makes a difference. You can see it kind of like reduces the effect sizes a little bit, but it doesn't really change the substantive results. Overall, they're really pretty similar across all the terciles. So it doesn't seem to have a huge impact on those state level deviations in educational attainment.
Why is the sample size 49?
So because it's in that second step. So there's only 49 states that I'm looking at. So I excluded Hawaii and Alaska, but included DC. So 49 states total, 51 minus 2. And so the state is the level of observation in the second step.
Guess I was just a little lost because in the very first model you presented, you actually included everything in the report.
Yes. So in that first model, I'm looking at the micro level, at the individual level. When I moved to looking at school quality, it made sense to follow the literature more closely in terms of going from the micro level to the state level. So using the micro level estimates to then assess the effects of school quality in the second step. And it especially made sense in this context because otherwise I have to include interactions with these different school quality variables and the polygenic index and everything in that model. So you end up having like, 6 interactions and all of the model gets almost too complex to interpret. And I found that this data reduction technique that's been used a lot in the literature was a really nice way of reducing the dimensionality so I could see what was going on at the state level. James.
So these are really fascinating to me, but I was wondering if you considered even looking at it by geographic region, like states within region, because the first thought I had when I saw that you were looking at school quality and student-teacher ratios was that there's like massive segregation happening, right? Specifically in the Deep South. And then I just looked this up. Brown versus Topeka Board of Education was 1954. So I would imagine that like in particular regions where there was deep segregation, where they now have to integrate, you'd see just really different people to teacher ratios.
Absolutely.
Where they were much worse in the South. I'm just assuming.
I feel like what we're kind of looking at here is the effect for whites. You're very right. And in fact, some of the studies have calculated like separate states for these regions of the South that were segregated. So they kind of acted like, okay, Arkansas is a different state if you're white versus if you're Black. And so we're going to use 2 different state level means. And so they actually had like, 56 states in the second, So for me, I think that, because I was only looking at European ancestry individuals, it didn't make as much sense to do that. If I wanted to go back and do this for across all ancestral groups, which I think would be fascinating, I could do that and go back to those educational statistics, and they do report them by race in that historical statistics.
I totally understand why you're just looking at it, your European ancestry. I just think that in terms of those outcomes that you were looking at, that there would be an effect, despite the fact that you're just focusing on whites, there would be just an effect of that environmental impact, that landmark decision that occurred in 1954, that likely served to drastically increase people to teacher ratios in the Deep South, right? Because now you have Black kids going into white schools. And I think a lot of the Black schools like either shut down or something happened to them and wasn't equitable, right? So I'm just wondering if that particular event in US history might have played a role, specifically in the Deep South, in terms of why you're seeing such huge effect sizes, specifically in that PGI tercile 1, where I think you showed very similar effects to in the last set of slides that you showed. Right?
Yeah, no, you're absolutely right. I think a lot of what we are seeing is being driven by the South. I think definitely and I think also in terms of, and I'll show that when I get into the earnings results, we're actually going to aggregate up even further to the census division, because I think most of the variation is occurring actually at the divisional level, rather at the state level, because there was just such strong clustering in terms of educational outcomes in the South versus, the New England versus and that's something that this literature is kind of played with too, is looking at the state level versus the census division level. So I think you're absolutely right. But I wish it would be cool if I had the power to actually, look within states. There is a cool study by David Cardin, a student of his, that's a current NDR working paper where they do that. They look at the state level stuff by parental education in the United States, and then they focus in on the South, and they look at specific borders in the South, but they're using the census, so they have this really large, the 1940 census, in fact, so they have a really large, rich data set. So I'm just a little bit more limited here. I'm always trying to get as much power as I can, but you'll see when we go to the earnings results that it was really at the census division level that I found things were most important. So then the next question, which it's more and more complicated, is what was the implication of the flattened gradient for earnings, which I really wanted to know. And so what I'm going to do is estimate the impact of these increasing investments in high school education on earnings across the life cycle, again, for the full sample and by PGI tercile. And I'm going to use this similar 2-step model. And again, this ends up just being way easier, especially for earnings, because you'll see that this earnings function gets more and more complicated so basically here I have the log of your cumulative earnings at these different ages. So 35, 40, 45, I'm going to estimate separate regressions for those different earnings cutoffs. And here I'm going to estimate those effects that I'm going to use in the second step at that the cohort division level. So I'm going to look at, I'm going to look at 3 different birth cohorts. So if you're born in the 30s, 40s, and 50s, and then I'm going to see what division you were in. So each cohort is going to have, there's going to be a fixed effect for each cohort division. So there's going to be 9 census divisions times 3 cohorts. There's going to be 27 beta coefficients that I'm estimating here. But and in particular, what I'm really interested in is the returns to education. So I'm looking at, how did the effect of your, level of schooling in your area affect the returns to your years of schooling in terms of its impact on your outcomes. And so, of course, I'm controlling for, interaction, then own education. Here again, I'm restricting these to sum to 0 so that you can interpret these rates of return as deviations from the national rates of return. And then I'm including a lot more controls here in this earnings function. So female, years of experience squared, whether or not your earnings were imputed, your marital status, and whether you currently live in a standard metro statistical area. So what's challenging about this is, I'm looking at their high school or their graduation, in this certain state, then I don't know where they live until they're in the HRS. So I'm also including, fixed effects for where they currently live in terms of census division, because I want to make sure that, the rates of return in the current, if you migrated, current state could be different. And then I have those region times year of birth fixed effects, those same state level controls again. And then I'm going to run those by, PGI tercile. So in the second step, then I can get this, nice kind of reduced form. Importantly here, I'm not looking at school quality. So because I'm kind of starting over with earnings, first I want to look at what was the effect of average high school education. So again, that exposure variable that we saw initially in terms of its outcomes on education. What were those outcomes for earnings at different points in the life cycle?
Sorry, what's the subscript K?
Sorry?
What's the subscript K?
Oh, so these are, sorry, you can't see those are the fixed effects for the current census division that we live in while you're in the HRS. And so that's kind of, controlling for differences in the returns to earnings based on where you currently live versus where you grew up.
Two questions. Do you have a follow-up first? The controls for years of experience and squared and marital status, especially, I'm wondering if you're shortchanging the effects by adding some mechanisms in here. That's one question.
Yep.
Probably not so much, but I don't know if there was a reason that they must be in the X vector. Maybe the more substantive question is, the title is about flattened gradient. You showed, I would say, the evidence that you showed that was of the gradient was of one margin of the educational distribution, correct? And not the other margin. That's maybe my question is, so years of schooling is all of them. So I'm wondering about seeing a version of this where you limit the sample to high school grads or below. That's where the flattening,
right.
So I don't know if it's a different question or not. Like, this is a question of flattening across the whole educational distribution, but leading up to this, one of the interesting findings was that it didn't affect all the different credentials, it seemed.
Right. No, that's a really good point. So, and I've been going back and forth. This is where I really need a lot of feedback, because I've been going back and forth with estimating this different ways. And I was using here, instead of using years of education, I was just using graduation from high school, so that I was in a sense, measuring the returns to a high school education. And yeah, the results just weren't as clear.
But when you do it that way, you still, like, if you're still in a sample if you graduated from college, right? So I think the complementary regression that I'd be interested in is among those who didn't graduate from high school or did, and that's it, because that's the flattening part, right? Well, maybe I'm overstating that. Your flattening results were yes, no high school graduations. But in subsequent analysis, yes, no associate, yes, no bachelor's. I don't think you had a gradient of the same, right? You see where I'm coming from about the flattening part, and whether I think my worry is that you have some flattening and non-flattening parts of the educational distribution that are all in here, and it might understate potentially your results if you like push them all together in a single regression. I think that's my question. If it's going to water down the results you have.
So part of it was, and I was thinking I could show the rates of return across these different, part of it too was I was looking at, okay, I'm really interested in the effect of high school, ultimately in the second step, kind of the high school movement on rates of return. And so I could do a high school movement on high school rates of return. And you're suggesting instead of estimating that in the full sample, just looking at it for individuals like no degree.
I think I'm suggesting it's a compliment, which is to say, I think this regression is not with this title because of the flattening is only during part of the distribution. I think this regression is about the PGI gradient in earnings across the educational distribution. It's just whether it's a flattening part is, I think, my question. I think this is still interesting results, but I think it's minor, which is it really about can it explain the flattening because you're throwing in people where it doesn't seem like there is flattening is the reverse.
Right.
If anything, your results suggested the opposite findings in those who are more highly educated.
Yeah. And so you would use like high school graduation here instead of years of education, or?
I think I'd like to see, the results where you actually limit the sample to that margin, those who are on one side or the other. So you're eliminating those who went on to associate's degree in college graduation.
Okay.
So they're just on the flattening side.
Okay.
It's not that I'm not saying replace it. You still want to do this.
So keep using years of education, but just restrict the sample to.
Well, the way I'm describing it, you're on one side or the other. So you're not high school graduate or you're high school graduate. So you can still use an indicator variable there for which side you're on, I think. Okay,
so using years of education. Yeah, it's so hard too, because I feel like in the literature, they always use years. They're always estimating returns to a year of education. And
totally right, but they're not talking about the gradient of a PGI.
Right. No, I know. No, and I've been going back and forth in my head about this. So this is like super helpful feedback because I agree. Okay, so using high school graduation, restricting the sample. Yeah, I'll have to look at that as well. So what do we see here? And I'm going to finally show you a picture rather than a table. This is interesting, I think. So down here, let me move this guy over so you guys can see this is kind of the last results slide, by the way. I know I'm still working on the school quality stuff for earnings. So this is again the impact of high school bar, basically on deviations in rates of return across states by age. So, these are each, these coefficients, these are regression coefficients. These are each from different models. So I ran the model for cumulative earnings at age 35, at age 45, at age 55, so we're getting, progressively older here. And, you can see for the full sample, kind of the strongest results being kind of early on, and then it kind of, goes down. I think what's really interesting is for this first PGI tercile, we see this strong effect initially of, graduating high school on deviations in rates of return, and then it just goes to zero. And so it seems like this effect of high school is diminishing across the life course, particularly for individuals in the lowest PGI tercile. The other two, it kind of stays pretty much the same. goes down still, but it doesn't go to zero. And I think, first of all, this kind of stronger effect that we're seeing here at the beginning is interesting in terms of how it overlaps with economic theory, a theory called signaling, which is that, basically your high school, your degree credentials matter most for your first job. That's where the employer isn't looking at your resume and seeing all of your job experience or all of your skills that kind of you built on these jobs. They're just really looking at like, where did they graduate high school? Did they go to college? So we see, I think that's partially why we're seeing this stronger effect, but it's really strong for the first PGI tercile. So it suggests that maybe kind of those early policy boosts might have helped initially for earnings across the distribution, but then over time that flattening of the gradient didn't translate into higher earnings necessarily. Whereas again, as the theory would predict later in the life course, maybe it's more about skills and other things.
So just to clarify, Lauren, this is earnings at age 35, at age 45. Okay.
Cumulative though. So
Up to.
up to, that's a better way of saying it.
Okay,
Up to, yeah.
I see.
So this is kind of where I'm now. And so, I want to go back, re-estimate these for different points in the distribution, and then also look at this for school quality. And the results that I've looked at, I haven't seen the kind of particularly strong effects for school quality in terms of how it's mapping onto earnings. But I need to really dig into it. I'd also like to look more into mechanisms, so that maybe I can say something more about what I'm seeing here. And so, any kind of suggestions on those lines would be really helpful as well.
I just want to follow up on Ava's question, actually. So if this is the same set of individuals, but you quantify the cumulative earning at different age point, why do you see reduced confidence interval over groups?
I think it's coming from noise. My guess is that it's coming from it could be measurement error in the earnings data. It could be that it's kind of getting maybe, as you aggregate that across the life course, it's getting more stable. So like the variation in earnings in these different groups. So at age 35, there might be more variation in earnings across these different groups than there. And then also just measurement error potentially in the data themselves.
Is it true that sample size is the same?
Yes, that is true. Yes, I'm always looking at the same individuals. Yeah. And again, there's some bias there because, I'm looking at individuals that have, first of all, I'm pulling men and women here, which has its complications. I'm looking at, these are people who worked their whole life, so, I'm not including individuals who maybe, I'm still including them even if they had a spout of unemployment for 5 years or whatever, they're still in there.
A zero.
Yeah, those earnings, those years are zero. And that's just a restriction of the data is that I just can't observe everybody.
I'm not sure, but I think the variability in the measure in the phenotype will affect the effect size.
Mm-hmm.
So I wonder if a close to zero confidence interval in, for example, the cumulative lifetime earning at age 65 tell you that there's just no variation in this measure across your samples. So of course, you also wouldn't expect to see any effect of any predictor you're investigating.
Yeah, no, I should look more into how that variation, because I think you're right that, I don't know, it's not totally. I think the other thing the gradient also kind of flat in terms of the age earnings profile. It really starts flattening around age 50. So before that, your earnings are just at the person level, your earnings are steadily increasing. And then by the time you get to age 45, 50, you're probably at your highest salary. 50, it might go up a little bit, but it's like on an individual level, it just flatlines.
Yeah, on an individual level, yes. But
and then exactly. And then between individuals, that's going on. So that could be part of also what's explaining that there's more variation across individuals leading up to that point, and then it kind of might flatten out more. maybe.
I don't know, I mean, I don't know a little bit about earnings, but I would think that, as you earn more, you actually accumulate capital and capital builds on itself. So you might actually see a divergence in, I guess this isn't earnings, it's not wealth, it's earnings. So,
But it's cumulative earnings. It's, you add every year and then it gets bigger and bigger and bigger.
Right.
I mean, one part I think is the zeros here. Like there's just like a big distance between a zero and if the average earner is $40,000 or $50,000 in each of these ages, like having those zeros plus 40 or 0 plus 0 plus 0 plus 40, I think those zeros are consequential here. I don't know.
Yeah.
it looks like there's a comment in the chat,
There,
maybe.
oh yeah, thank you.
Maybe.
Yeah, there might also be more zeros here earlier on. And then,
And everybody's asking about just men, like you. There, yeah.
Yeah, I think it's in the same vein as the rest of what you guys are talking about. It's just, for a lot of this early literature, I feel like people focus on men, which feels bad as a woman to say that. But since we did have lower labor force participation rates, going to impact the selection into this and whatnot.
absolutely. And I, originally when I wrote this paper, I did everything separately by men and women and for earnings. And I will definitely estimate this separately for men and women. I've been finding it just overall more helpful to aggregate everyone just because it increases the power. Of course, I'm controlling for sex. I could also create sex specific, like all in the same regression, sex specific beta deviations by census division, and then kind of there's a couple different ways that I could approach that. So yeah, I have to kind of look at that more closely and see how this holds up across men and women, definitely. But yeah, if you have any thoughts on
One other thing that I was thinking about is, how this might be potentially confounded by just the also the time, right? Like, so you showed that probably by 1970, those people that were graduating high school was like at 90%. And there's like this education inflation that kind of like happens. So by the time these people are 50, does that maybe a high school education means a little bit less in the labor market than it did at the same, maybe it means less in 2010 than it did in 1990,
Absolutely. Yeah, no, I was thinking about that too. And I think I'm hopefully taking care of some of that. I have fixed effects for birth year in there. So I'm hopefully absorbing some of that variation across birth year cohorts in terms of how that might be influencing returns to education across the life course. So trying, but it could be that, especially a lot of these individuals may not, especially, so I did look, because it's interesting when we look at the summary statistics, there are individuals who didn't graduate high school who are in the top tercile, they're across all the terciles, but you're more likely to not have graduated high school if you're in the bottom tercile. So part of, you're absolutely right, what we might be seeing here is that, over time, those effects, these people went on to get more education. So that's kind of why we still see like a lingering effect of education here, because it's picking up then on the fact that they got higher levels of education. Because remember, these are rates of return across total years of education. Whereas here, they were maybe more likely to get a high school degree, and then over time that flattened. So yeah, I think that's a really important point. Yeah, and hopefully I can suss that out a little bit more too if I look at rates of return by high school, college, not just years of education, different samples. Yeah. Let's see, just to sum up here, I think what these show is that, or kind of, what my goal is with this study is to use genetic data to enrich our understanding of inequality in education and the effects of social policy and how those effects persist as people age across the life course. You see an evidence of a negative interaction between the polygenic score index and increasing high school completion rates across states. And this is interesting because high school completion was the relevant policy margin for these cohorts. So I'll kind of just say what we So it could be, you know, that policies that target a particular level of educational attainment may reduce the genetic gradient in that attainment. Controlling for parental education reduced the effect size of the polygenic index by about 30%. That's been, you know, shown in the genetics literature on twins and everything. So no surprises there. We know it's correlated with the PGI due to genetic inheritance and genetic nurture, and evidence of a similar compensatory relationship at lower levels of attainment. These widely used state level measures of school quality may be acting as mechanisms. But overall, all these results, I think, appear to be largely driven by increases in high school completion rates, and perhaps acting more mechanisms for the lower levels of the PGI tercile. And then, this flattening of the genetic gradient for high school completion initially resulted in higher lifetime earnings results, but then this effect appears to diminish in later years, particularly for the lowest PGI tercile, which is kind of predicted by this signaling theory. So maybe that's not entirely surprising. Coming back to Q's earlier comment, you know, is this moderation we observe evidence of a gene environment interaction? And I'm going to be really cautious here. I'm going to say it's really not definitive evidence. You know, first of all, these increases in educational investments didn't occur randomly, and these state level investments in schooling may serve as proxies for other characteristics of the environment for which students were raised that I'm not capturing or controlling for. And also, this is the point that Q is making, that the interaction may reflect a reduction in the variance rather than a linear change in the association between the polygenic index and you know, secondary degree completion. And that maybe is to be expected because we have these changing norms, and that's going to shift where we observe disparities in the PGI by education and the educational distribution. Overall, I think we need more research to clarify whether specific aspects of the schooling environment may be moderating this population-wide genetic gradient. I think it's an interesting question overall. Is this something we care about moderating, or kind of, you know, is this something that we care about as a society? So I'm also interested to hear your thoughts on kind of the implications of these findings and yeah, what your takeaways are with that. So yep, that's all I have. I know we don't really have a lot of time, so, but you guys have been throwing some good comments my way. So any other thoughts or comments? Shoot,
I was wondering, like, for the regressions when you used education, you used the state where you spent most of your finance using. So I know HRS has like the longest term of occupation, stuff like that. So do you think HRS has like a state where you have spent like your longest term?
No, they don't. I wish. I know they're working on getting more life history data on participants, but right now all we know about their geographic residence is where they were born, where they spent their primary schooling years, and then, you know, where they are while they're in the HRS. And while they're in the HRS, we also know more detailed evidence on the county census tract they live in. But for childhood, we just know state. So,
so when you are considering current state, and then your regressions have like earnings up to 35, up to 41. So that current state means if I am age 60 in each other, so current state is where I am in 60. But you are considering the earnings up to 35, and I might have been in some other state.
Correct. So that's, yeah, this is another thing that I'm mulling over, because I'm controlling for where they are currently in the HRS, but that might be different. It does seem like there's very few people that switch states overall. So there's very few people that you know, changed from those state they were educated in. Maybe like 20% are in a different state in the HRS. So we're kind of just assuming not a lot of migration here, which that's definitely an issue. The other thing too is that I'd like to estimate those earnings regressions with and without those controls, because actually when we include those controls for current census division, we're identifying off of migrants. So we're actually, that regression is identified off movers. So I'd like to, you know, look at those results with and without those current state controls, because migrants obviously might be very different than people who didn't migrate. Yeah, so there's all these this has become this very complex thing because there's just so much going on. But I'm hoping I can say something about human capital theory. I'm hoping that I can say something meaningful to add to the econ literature, and also kind of showcase how we can use these polygenic indices in ways to talk about social inequality. And it's unique that we have these light course earnings. So something in particular about that. So yeah, thank you everyone. This has been helpful to present it at this stage. I'll